Hi, so this is the explanation for the fan cart with a constant velocity to the right or in a positive direction, otherwise set. We got our two graphs here, our position time graph and our velocity time graph. For our position time graph, we have a linear line that's going up to the right, which is what we wanted because for a constant velocity, we want a linear line. And if it's in a positive direction, we want it going up, which is what we got, released close to what we got. So our we have our y-intercept that's right here, uh, saying that at time equals 0, so at 0 seconds, our cart is 0.3652 inches ahead of the starting position. And then our slope for this line is 28.68 inches per second, which is our velocity, or average velocity, I mean. So for every second, the car moved 28.68 inches. That's what it's saying, basically. Um, yeah, okay. Velocity. This is our velocity graph for our position um, time graph. We calculated velocity just using the derivative for every point. So here I took a best fit line, and I got that the linear fit for the constant velocity to the right has a slope of negative 7.615 inches per second squared. This is actually our acceleration, and our acceleration is should have been 0 if we had a constant velocity, but since I couldn't get really a constant velocity, I this is the closest I got, and our acceleration should be 0, but it's actually negative 7.615 inches per second squared. Um, our y-intercept says that at time equals 0, our car was going 32.33 inches per second already. And our velocity graph should have not come out like this. It should have been in a horizontal line. And I also took the integral for the velocity graph, which is basically the area under the velocity graph, which, if you remember, the area under velocity graph is the change in position. And for our integral, we got 28.58 inches per second. Oh, no, 28.58 inches. Sorry, I was reading the thing. And if we look over here, our time equals 0, we're at 0 position, and at the final time, we're about at 28 inches, which is our change in position. And so this is exactly what we expected, except for a velocity graph and a little bit off on our position graph. But as I explained, this is just our slope and our y-intercept, and this would give us our position at any time in between this interval. And for our velocity graph, this is just our slope or our acceleration, our time, and our y-intercept, which is our initial velocity, and it would give us a velocity at any time between these 2 points. And this all represents the motion of a cart with a constant velocity moving to the right or in a positive direction. And that's it.